It also shows the influence of architecture. Here you have a sort of modular architecture in A, where you have a set of elements which are interconnected, but in a certain way. It turns out this breaks down into individual little consciousnesses, very, very minimal ones with 2 concepts each, but there is no larger entity at all. So you don't have one big consciousness, you have a lot of small ones. In the middle you have another interesting system, 5 elements, all-to-all connectivity, majority rule, if more than 3 fire, I fire. And in that case, the system is one complex, it forms one entity, but it has only 5 concepts, and they're all elementary concepts, the ones specified by each individual element, and by the way, they're all the same. So there's only one star, if you wish, in the past and in the future. It's a totally trivial system with a minimum value of big phi. So it's minimally conscious, only conscious of one little thing, this and not this. On the right is a system with 5 elements, same logic, but only 3 connections per element, and they are different from each individual element. So we have introduced some differentiation. It's not homogeneous like before. Now suddenly it is still one entity, so it's a complex, but big phi is much higher, it's 10.75, and it has 30 different concepts of elementary and higher order. So now it is like something to be that system, and it's something more interesting than before. It breaks many symmetries. So we assume this is sort of true for many systems if you could analyze them properly. Another obvious consequence is that the consciousness can be graded. You can see here by changing the strength of the connections, which can happen in our brain, from high to medium to very low, you can have one entity with high consciousness, so to speak, another one with much less so, but still one entity, and then it breaks down into sub-entities. We think that happens when you go into sleep, as I'll show you. Another counterintuitive consequence is that a system made of inactive elements that supposedly do nothing, okay, these are copy gates that just do nothing at all, they are all off. This could be neurons that are off, will still generate consciousness of a certain kind. So you don't need to pass messages around or signal. It's an intrinsic property of something that is and has that ability of constraining the past and the future. Another consequence, you can have a very simple system, like a photodiode with memory there, which can actually generate a minimum amount of consciousness. That's actually the smallest amount. We call it really minimally conscious. It is like something to be that photodiode, although it's so trivially low that it doesn't even make much of a difference to talk about it, but it is a minimal distinction. It's this rather than not this. It doesn't matter whether you're a photodiode, a blue detector, or a thermistor. In that case, intrinsically, it just feels like just a little bit and nothing more. An interesting consequence is that the purely feed-forward system disintegrate. It's not a system, according to this theory, so that, in fact, if you take even a very complicated feed-forward system, there's nothing it is like to be that. You can show this because recursively nothing can act back on itself, and therefore there is nothing there. We can use it, but it doesn't feel like anything. And a key consequence of that is that you can build 2 systems, one on the left, which is recurrent, and one on the right, which is the equivalent, purely feed-forward version of that recurrent system, which have exactly the same input-output function here up to a t equal 4. So they do exactly the same job. You could treat them, they behave equivalently for any question and answers you want to get from them. And yet, if you do the analysis according to IIT, the one on the left feels like something, is something, exists. The one on the right, we can use it, but it doesn't exist at all in and of itself. So there is functional equivalence without conscious equivalence. That's